Hey everyone, welcome back to Cracking the GRE Math Subject Test, Linear Algebra. This is our last problem in the Linear Algebra chapter. We're at number 20. In this problem we're given a complex matrix. It's the first time we're given a complex matrix. And we're asked to find the eigenvalues, or at least one of the eigenvalues. Well, here you could just use the definition of the eigenvalue. Remember, the way to find an eigenvalue is with the characteristic polynomial or characteristic equation. I'll just remind you what that means. You have to take determinant of lambda I minus a equals 0, where lambda is the eigenvalue. So this will give us, we have to take the determinant of lambda minus 2, 2 plus I stays the same, 2 minus I stays the same, so 2, and lambda minus 6. This is lambda. Okay, and set all that equal to 0. Well, the determinant of this is going to be lambda minus 2 times lambda minus 6 minus 2 plus I times 2 minus I. All of this has to equal 0. Okay, so let's write this out. We get lambda squared minus 6 lambda and minus 2 lambda gives us minus 8 lambda. And then negative 2 and negative 6, it gives us a positive 12. Now we have minus, and then I'll write here in parentheses, 2 plus I times 2 minus I, remember that's like a plus b times a minus b. So that's a squared minus b squared, or 4 minus I squared. Well, remember that I squared is just negative 1. So negative and negative make a positive, so that gives us plus, this whole thing is just a plus 5. And here we have a minus, so this is going to give us a minus 5. And 12 minus 5 is 7. So we can write this as 7 lambda squared minus 8 lambda plus 7. If we factor this out, what do we get? Well, we have a lambda and a lambda. We have a 7 and a 1. And since it's a minus and a plus, we're going to have to do minus minus to get minus 8 lambda and plus 7. So our options are either lambda equals 7 or lambda equals 1. 1 is not one of the multiple choices, so our answer is C, 7.